All right, so let's try to understand what are simultaneous equations. Simultaneous equations are basically those equations that actually help you find a solution, or they give you information about something, but in different angles or perspectives. Like this, in this case, you can see an equation number one and an equation number two, and they will actually be telling you something about this parameter y. They are the functions of y, like y is equal to 2x plus 1. This is an information about y, that how y varies with x. And there's another equation, y is equal to y is equal to x plus 2. This is also giving you some information about y, but there has to be one solution. Like if we plot these two equations on the graph, we're gonna have different graphs, but there has to be one solution for like that actually is true for both of the equations. Like there is one value for x. There could be, as you know, infinitely many values for x. That could be our inputs, and we have infinitely many outputs. And similarly, in equation number two, we could have infinitely many values for x, and we could have infinitely many outputs for y. But there has to be at least one, there has to be one solution or one such value for x that is true for both of these equations and gives the same output for y. Let's actually try to draw these equations on the graph paper. So when x is equal to 0, let's construct the equation number one first. When x is equal to 0, y is equal to 1. So we have a point here. When x is equal to 1, y is equal to 3. So we have a point here. When x is equal to 2, y is equal to 5. So we have a point here. When x is equal to 3, y is equal to 7. So we have a point here. So if we, join these points together, we get to a line. Uh, Let me try to do it precisely. That's not precise. Okay, that's better. So we got a line something like this. And if we plot the second equation, where x is equal to 0, y is equal to 2, when x is equal to 1, y is equal to 3, when x is equal to 2, y is equal to 4, um, that's not exactly here. When x is equal to 2, y is equal to 4, so something somewhere over here. Okay, when x is equal to 3, y is equal to 5. So as we can see, this blue line actually goes this way. Let me try to do it a bit more neatly. Yeah, something like this, right? So you can see the equation number one is the red one. It goes all the way up. It has greater gradient. As you can see, why does it have a greater gradient? Because if we, just write the general equation for a line y is equal to mx plus c, which we have discussed in the previous videos, that m is actually going to give you the gradient. If we compare this equation, we have 2 here. This means that equation number one has a graded gradient. So this is equation number one, this is equation number two. So this has a greater gradient, that means it will have a greater slope, and that is why it is more inclined than the equation number two. Because here x plus 2, the coefficient of x is just 1, lesser than 2. So it is going to have less gradient than 2, so it is a little bit less inclined and its slope is less. And we can see that. And also this point C actually tells you where the graph or where the line would intersect the y-axis. And you can see the first equation has c equal to 1, so it is intercepting y at 1. And the second equation has c equal to 2, it is intercepting y is equal to at 2. So you can just see the demonstration or illustration of that concept here as well. So let's actually try to find out where these lines intersect. So these lines intersect at this point, right? So this point. So at this point, you can see that the value for y is 3 and the value for x is equal to 1, right? So these are the coordinates. And if we can just write them down, we can just write them down like this as well, 1 comma 3. So let's actually put a y equal to 3 here and see if x is equal to 1 or not. So if y is equal to 3, then yeah, 1 plus 2 is equal to 3, x should be equal to 1. If we put x to be 1 equal x to be equal to 1 here, let's see what do we get. X 2 times 1 is 2 plus 1, that is 3, and y is equal to 3. So this solution is actually true for both equations, hence this is the solution of these two simultaneous equations. They are actually giving us information about if you only had one of these equations, only for example you had equation number one, you would never be able to find out the value for y, because you could have infinitely many values for x and as similarly have infinitely many values for y. But if you have just one more equation, like equation number 2 here, then you actually combine these two equations together, you can plot them together, and the line the point at which the lines intersect is going to give you the solution, because at that point the both values for the both equations, the value for one value for x will give you one value for y. So that's how we actually find out the solution of simultaneous equations graphically. In the next video, we'll be talking about how we can solve these equations without actually getting into this trouble of making tables and graphs and try to draw and find an intersection point. We can just do it algebraically. We'll find out how in the next video.